Hello, this is Real World Assignment 2. In this assignment, we got the red wine dataset. In this dataset, it consists of 6 columns and 1599 rows. As you can see in the picture which is attached in the slide, this is a sum of the data from the red wine dataset in which we have to do all our operations and coding on this dataset by taking the reference of this dataset only, in which at the end we have to calculate the predictive wine quality. Now coming to histograms, here you can see the histogram of pH variable and total sulfur dioxide and as well as a histogram of quality also. In this slide you can see the histogram of citric acid, chlorides and alcohol. I created all these histograms using that dataset, red wine dataset only. Coming to the transformation logic, this is the first and basic step while predicting the wine quality, and I did this transformation logic on the basis of skewness value. First I calculated the skewness value. If I get the skewness value is greater than 1, then I need to apply transformation, log transformation, and then apply transformation. And if I get the skewness value less than -1, then I applied polynomial transformation and then applied Z transformation. And my last condition is that if above two condition is dissatisfied, then I applied only mean max transformation. So this is my transformation logic in my code. This is my error measure table which contains all the values for every model. This is my summarizing weight table contain all the values for my selected 4 variables. Importance of variables. As I mentioned earlier, the red wine dataset contains 6 columns, with the sixth column representing quality. So we need to select only 4 variables out of the first 5 columns. And I selected citric acid, chlorides, sulfur dioxide, and pH. Scatter plots of variables. Here I have attached scatter plots comparing the first 5 variables with quality. The reason for selecting these 4 variables is because for citric acid, the trend line has a subtle upward slope, indicating that higher citric acid levels may slightly enhance the accuracy of quality predictions. Coming to sulfur, there is an inverse relationship between sulfur dioxide and wine quality. That's why I selected sulfur. And for chloride, the scatter plot for chloride shows that most values lie between 0.05 and 0.1, which appears to be the most effective range for predicting wine quality. And for pH, at in the scatter plot, at some level pH level remains stable at specific point, contributing to more precise predictions. Best fitting model of data. I got QAM as the best fitting model of my selected data because QAM model got the lowest values, which makes QAM model as the best fitting model for this data. Here are the best conditions for the higher quality which is mentioned in the table. Here I am predicting the value by using the new input and I got the predictive quality as 3, and I think this value is very reasonable because while checking these plots these values does not fall under the best condition. Implications and limitations. For implication, it is a decision making and identifying key factors. And for the limitations, it's completely based on the data, which is completely depend on the quality and quantity of the data. Thank you.